All right. Hello, welcome. My name is Paul Dardo, and my coworker here is Surya Naredla, and we're here to talk to you about OpenStack Cinder Performance. I find your lack of faith disturbing. Go ahead. So what we're going to do is give you a little idea about how do you get started looking at Cinder Performance, what are the things you need to do, what are some of the tools you need to consider, what are the things you need to keep in mind, and when things aren't working quite well, what are some things you need to think about for deeper investigation. But the first thing we need to think about is getting some server monitoring infrastructure put in place. And the reason for that is that although really what we're after is performance, we have to have some idea of how the systems are performing so that we know what the system's metrics look like when things are going well as what they look like when they're not going well. So the first thing we're going to do is we're going to use Prometheus in this example. Step number one is we're going to set up what's called a node exporter from Prometheus. And this is kind of a canned generic exporter that provides a whole wealth of metrics available to Prometheus. And it's kind of a general purpose, and it's a great starting point for setting up your Prometheus. So step one, set up your node exporter on each node and start it. The Prometheus node exporter comes in a tar.gz. You just unpack it, set it up in a directory, and execute it. There's really no configuration needed in order to run the node exporter. Second step is you need to set up your Prometheus server and configure it and then start it. Go ahead. Okay, so there's a little bit of configuration needed in setting up your Prometheus server. So like with the node exporter, you get a tar.gzip, you unpack it, and then there are a few files in the directory, but there's one configuration file that you do need to set up, and that's called a prometheus.yml YAML file. So what you do is you open up this file to edit it, and if you look at the red rectangles I have in the lower left corner of the screen, you'll see a section called scrape configs. And this is the part where you tell Prometheus, here's what I want you to gather up, right? That's the section that scrape configs is dealing with. There you configure a job name, and in this case we're configuring a job, we'll call it node, because node is kind of that's the common name given for running node exporter. And probably the most important part of all is what's shown right on the bottom line here in the targets section. And this is where we give Prometheus a list of all the nodes that we want it to monitor. And so for each one, it's a list of the IP address and the port. The default port used by Node Exporter is port 9100, as you see here. One of the interesting things to keep in mind about with Prometheus is it's a pull model, unlike, say, collectd, which is a push model. So in the case of a pull model, our individual nodes don't need to know where our Prometheus server is. Only the Prometheus server needs to know where the nodes are that it's going to monitor, and it pulls the metrics that it's interested in according to the intervals that we have configured here. The defaults work pretty fine. Go ahead.
So the verify metrics.
Okay, so once we have our Prometheus server configured, we start it, we just run it. It'll get started, and then since we've configured it to know where our different nodes are that we want it to monitor, it should go out and start pulling that data for us. But what we want to do is we want to make sure that it's actually pulling data as we expect it to. So we want to verify that. So what we do is we go to the URL for our Prometheus server. You type in the IP address of your Prometheus server. It's port 9090. And using the URL you can see up here on the screen, consoles-node.html. This will provide a list of all the same IPs you've configured in the YAML configuration file. But more importantly, you will see the 3 columns showing whether that node is up and whether any metrics have been received for CPU or memory utilization. If you click on one of those links on a particular node, you will see it bring up a graph of, there's a graph for CPU utilization, but since this talk is centered around Cinder, More importantly, we will want to see things like disk I/O utilization and perhaps some file system usage, primarily the disk I/O part. Go ahead. So now that you have some monitoring infrastructure in place, the next thing to think about is what are some of the baselines and to be able to identify what does good performance look like in terms of your monitoring, the metrics that you see being captured from Prometheus. What does that look like when things are going well? And then what do things look like when they are not going well? But it's real important to have that notion of what does it look like when things are running well, so that you have that basis for comparison when things aren't going well. Go ahead. Okay, so let's start with something very simple. And you're sitting on a VM, you've got your Cinder volume attached, and your very first thing you want to find out, hey, how well does this thing perform? What can I reasonably expect out of this particular volume I have attached? The most basic way of doing that is with the DD command. So in the top blue box, you can see that I'm issuing a DD command where I'm pulling from dev0 and I'm writing out to a file on my Cinder volume. And I'm using a block size of 1 megabyte and a count of 10,000. So this would be a 10 gigabyte writing of data out to this disk. You can see that it prints out, we have 753 megabytes per second. Not bad. Next step is we should drop the caches before we run the read, so that we're not reading out of the cache that the system is already has that data cached. After we move on to something a little more sophisticated, we use FIO, which stands for Flexible I/O Tester. FIO is very sophisticated, but it can be run in two modes. You can either give it command line arguments, or you can set up an INI style workload file, configuration file. One of the things that's most important to keep in mind with FIO is the I/O engine. Most important for us would be either the sync or the libio or POSIX AIO I/O engines. Go ahead. Okay, so this is what a very simple FIO configuration file would look like. And in this case, we're really just focusing on kind of the bare bones minimum of what it would take for us to run a sequential write job. So we tell it read write is equal to write. In this case, that's sequential write. We're telling it we want a POSIX AIO I/O engine, the size, direct, so on and so on. We save that to a file, and then we can execute it. Go ahead. So we kick off our FIO execution. Up at the top of the screen, you see FIO and then the name of the file that we just configured. It'll run, and then once it's finished executing the workload that we've configured, it'll spit out all of this data. And there's a lot to look at here, but I would like to call your attention to two main areas. The light blue box, which kind of gives you a nice summary of what's your IOPS, what's your bandwidth, and so on. The red box gives you a lot of detail about what your latencies are. Okay? So this is where you look to see various percentiles, your minimums, your maximums, what it's like from the client's point of view, what's happening from the server's point of view. But these are kind of the two main areas you would want to focus on when getting started with FIO.
I think we're almost out of time.
Okay. Now, once you have your setup in place, you have an idea of how things are running, you have your monitoring system in place, you've done some tests, and things may not be working well as you start using your systems more and more. What I would suggest is as you have to start playing detective to figure out where your bottlenecks might be, what I would suggest is you start from bottom up. So start at lowest level, work with your hardware, see how it's configured, double check things, how's your network set up, what kind of hardware you're using, your controllers, your BIOS, all of these different things. Once you get beyond that, you check your network. You can use iPer for point-to-point connectivity to make sure that all your network points are giving you the performance you expect. And then you lastly look at your storage backend. Make sure it's configured the way you would expect it to be. In summary, start with your server monitoring. Make sure you have it in place and you've got some baselines on what good performance and not so good performance looks like. Use tools like DD or FIO to start kicking the tires and getting more sophisticated about what types of workloads you want to use to measure. And then evaluate your results. Are your results acceptable or not? Are they realistic? If you have some problems where things aren't working to the extent that you think they should, spend some time looking for the bottlenecks, but refine all of this over time. It should be an iterative process that you go through over and over. You might want to start introducing multiple scenarios to consider. Once you get more sophisticated with more data, you can get to the point where you're doing performance curves and even performance modeling. A lack of faith, as we mentioned in the title, is really a lack of data. And what I'd like to leave you with is that you don't take your performance on faith, you take it on data. All right? And finally, I've left you with a few references here. The first link is a link to Prometheus. We only scratched the surface of Prometheus. Here's where you could go to get more details on that. The next link is on FIO, the Flexible I/O utility. And lastly is a link to what's a project called Store Perf, which is when you're ready to get into something that's more sophisticated and more advanced, that's a really good place to start to find out, okay, what do I do next, and what are some more sophisticated steps that I might take for my Cinder performance? Thank you.
Thank you.